We'll build a complete Lisp interpreter from scratch in a single Java file. You'll see how to tokenize, parse, evaluate, and create a REPL. This is the same architecture behind languages like Scheme or Clojure, distilled into about 350 lines. We define an expr base class and 6 subclasses: numbers, strings, symbols, lists, lambdas, and built-in functions. Each node type holds the data it needs to represent the parsed code. This tree will be evaluated recursively. An env stores variable bindings. It can have an outer environment for nested scopes. Define adds a new binding, lookup searches this environment and then its outer ones recursively, mimicking lexical scoping. The tokenizer breaks the raw input string into tokens, parentheses, quote, strings, and atoms. It skips whitespace and handles string literals by collecting characters between double quotes. This is the first stage of parsing. The parser recursively builds an AST from tokens. When it sees, it creates a list expr by parsing items until a single quote expands to, quote. Atoms are tried as numbers first, then symbols. This is a classic recursive descent parser. The static block creates the global environment and populates it with built-in functions. Each built-in expr wraps a Java lambda that performs the operation. For example, sums all arguments. Char and CDR access list parts, list creates a new list. Eval dispatches on the expression type. Numbers and strings evaluate to themselves. Symbols are looked up in the environment. Lists are the heart of the interpreter. They can be special forms like define, lambda, if, quote, or function applications. Special forms are handled directly in eval. Define binds a symbol. Lambda creates an anonymous function object. If evaluates its condition and chooses the appropriate branch, anything not false or 0 is truthy. Quote returns the unevaluated argument. If the first element of a list is not a special form, it's treated as a function call. We evaluate the operator and arguments. Built-ins are invoked directly with the evaluated arguments. Lambdas create a new environment with their parameters bound, then evaluate their body in that environment. The main method runs a read_eval print loop. It reads a line, tokenizes it, parses it into an AST, evaluates it in the global environment, and prints the result. Errors are caught and displayed gracefully. Typing exit quits. The interpreter evaluates arithmetic, definitions, lambdas, and conditionals. It shows that our tiny Lisp is fully functional. You've built a complete Lisp interpreter in pure Java. This demonstrates the core of every language: tokenizing, parsing into an AST, and evaluating with an environment. You can now extend it with macros, tail call optimization, or a standard library.